Hello and welcome to this lesson for OCR A-Level Physics on Module 4 Electrons, Waves and Photons in the topic of waves, looking at the concept of intensity. So if we've been successful and we've learned in today's lesson, we should be able to understand what the intensity of a progressive wave is, calculate the intensity of a progressive wave and understand the link between the amplitude of a wave and its intensity. So we're going to be looking at the following part of the OCR A-Level Physics specification 4.4.1 Wave Motion. Now, wave emitters can be classified due to their power output. Now, this is because all progressive waves transfer energy and therefore have a power output. Now, the name given to the power output for an emitter is the luminosity. So the luminosity of an emitter is the amount of energy radiated out by the emitter per second. Now we can therefore measure the luminosity of an object in watts. Now the intensity of an emitter is the power received by an observer per unit area. Now the total definition is that the intensity of a wave is defined as the rate of energy transmitted, the power, per unit area at right angles to the wave velocity. So we can therefore say intensity is the power received over the area. So intensity is therefore measured in watts per meter squared, as power is measured in watts and area in meters squared. Now we can consider the intensity as the effective brightness of a light source. Now the area of the sphere of radiation emitted is proportional to the separation between the emitter and the observer squared. In essence, it's going to be the radius of the sphere squared. So as you can see here, you can see our separation, and therefore the area is proportional to the separation squared as it is a sphere. So therefore what we can say is it's also in essence the radius of the sphere squared. So if the energy has been emitted from a point or a sphere, then the intensity obeys the inverse square law. Now this is because the energy spreads out in spherical shells. So as we know, area is 4 pi r squared, where r is the distance between the emitter and the observer. So what this means is that when the emitter is twice as far away, the intensity and the brightness is 4 times less as the energy is spread out over a greater area. Now you can mathematically prove the inverse square law, as we can say I is equal to k over r squared, where k is a constant, so therefore k is equal to I times by r squared. So if you multiply values of intensity and separation squared, then they should always give the same value, this k. So therefore it does also mean that when the emitter is 3 times as far away, the intensity and the brightness is 9 times less, as the energy is spread out over a greater area. Now to use the inverse square law, you need to assume that the emitter gives out an even amount of energy. There's a constant intensity in every direction. And in addition, you need to assume that there's no absorption of the wave energy. So let's have a look at an example. The average distance from the Earth to the Sun is 150 million kilometers. The intensity of radiation received by the upper atmosphere is 1400 watts per meter squared. Calculate the total power output of the Sun. So we know intensity is power over 4 pi r squared, so power is equal to I times by 4 pi r squared, so 1400 times by 4 pi times by 150 times 10 to the 9 squared is 4 times 10 to the 26 watts. So the inverse square law states that as the distance from the emitter increases, the intensity decreases as the energy transferred by the wave spreads out. Now the energy of a wave is represented by the amplitude of the wave. So as such, when the distance from the emitter increases, the amplitude of the wave decreases. Now decreased amplitude means a reduced average speed of oscillating particles. Halving the amplitude results in particles oscillating half the speed and a quarter of the kinetic energy, as kinetic energy is a half mv squared. So this tells us for any wave, the intensity is directly proportional to the square of the amplitude. So we can say intensity is proportional to amplitude squared. Now this can also be written as intensity over amplitude squared is equal to a constant. So we can say that doubling the amplitude of a wave will cause the intensity to quadruple. Tripling the amplitude of a wave and the intensity will increase by a factor of 9. So we can also say that intensity is proportional to frequency squared as well. So what this means is that if the frequency or amplitude is doubled, then the intensity of any wave increases by a factor of 4. So to summarise what we've looked at in today's lesson, we looked at what the intensity of a progressive wave is. That intensity is the power received over the area, and that the intensity is proportional to amplitude squared. So if we've been successful, and we've learnt in today's lesson, we should be able to understand what the intensity of a progressive wave is, calculate the intensity of a progressive wave, and understand the link between the amplitude of a wave and its intensity. So thank you for watching this video on intensity, which is part of the waves topic in the module Electrons, Waves and Photons for OCR A-Level Physics. Thank you so much and have a lovely day.